Hi, welcome to this Corbettmaths video. In this video, we're going to look at the video solutions to the Corbettmaths practice questions on the gradient. If you need any extra help on the gradient, if you go to Corbettmaths and go to the videos and worksheet section and scroll down to video numbers 189 and 190, there's dedicated video tutorials there on the gradient. Alternatively, you can scan this QR code. But in this video, we're going to focus on the video solutions to the practice questions, so let's get started. Okay, let's have a look at our first question, question number 1. So question number 1, we've got this grid and we've got this line called line L, and line L has been drawn on the grid and we've been asked to work out the gradient of this line. Now there's actually quite a few different ways we can find the gradient of a line. One way is to actually look at the line and to go 1 unit across. Now not necessarily 1 square, 1 unit across. So here 1 square is 1 unit, but just be careful there. So we could go 1 unit across and see how many units up you go. So if we go 1 unit across, we go up 1, 2 units. We're going from 1 to 3, so we're going up 2 units. So the gradient of this line is 2, because if we go across 1 unit, we go up 2 units, across 1 unit, up 2 units, across 1 unit, up 2 units, and so on. So the gradient of this line is 2. So that's one approach. So go across 1 unit, not necessarily 1 square, going across 1 unit, and then see how many units you go up. So across 1 unit, up 2 units, across 1 unit, up 2 units, and so on. So the gradient of that line is 2. That's one approach. Another approach is to use the formula m, the gradient, is equal to the rise divided by the run. And I use this quite a lot, rise divided by run. So the rise of the line divided by the run of the line. So what you do is you choose 2 points on the line. So we can choose any 2 points. Now in terms of this line, I think there's a few points that would be better to choose than others. So I think this is a good point to use, the 0.01, that would be a good point to use. The 0.13 would be a good point to use here. The 0.25 would be a good point to use. And the point up here, the 0.37 would be a good point to use. And the reason that they're good points to use is because the line clearly goes through those points. So it clearly goes through this point here, which is the 0.13. I wouldn't necessarily choose this point here. So I wouldn't choose necessarily this point because we don't know the exact coordinates of that point. So what we're going to do is we're going to choose 2 points on the line. So I'm going to choose this point, the 0.01, and I'm going to choose this point up here, the 0.25. I could have chosen that one, 13 or 37, but I'm just going to choose those 2 points. And then what I'm going to do is I'm going to make a little right angle triangle. So I'm going to go across, and then I'm going to go up. And as you can see there, that's a right angle triangle. And in terms of that right angle triangle, we can now find the run and the rise. The run is how far we go across. So we're going from 0 across there to 2 across. We're going across 2 units. Again, don't necessarily count the lines because it's not always a nice scale. This is a nice scale, each line across. Each time we go across one line, we're going across 1 unit. But just make sure you're looking at the units. So we're going from 0 across to 2 across, so the run is 2. In terms of the rise, we're going from a height of 1 up to a height of 5, so the rise would be 4. So now what we're going to do is we're going to do m, the gradient, is equal to the rise, which is 4, divided by the run, which is 2. And 4 divided by 2 is equal to 2, so the gradient of that line is 2. And that's it. So one approach is to do it by inspection, to go 1 unit across and see how many up you go or down you go, and then that would be the gradient. Another approach is to do this rise divided by run. So what we done was we chose 2 points on the line, made a little right angle triangle, and then done the rise divided by the run. Another approach is to use another formula, which is m, the gradient, is equal to y2 minus y1 divided by x2 minus x1. Now I use that formula quite a lot whenever we've just been given the coordinates of the point. So perhaps whenever there's been no grid drawn for us and we have 2 points and we need to find the gradient of the line passing through those points, I use that formula quite a lot. But I'll just show you how we can use it for this question as well. So this is the gradient of the line y2 minus y1 over x2 minus x1. It seems quite complicated, and as I said, I tend to use it more whenever we don't have a grid. A grid like this, I would tend to just make that little right angle triangle and do rise divided by run. But I just want to show you in this example how you would do it. So the x1 and y1 stand for the coordinates of one point, and the x2, y2 stand for the coordinates of another point. So I'm going to choose 2 points on the line. So let's choose the same points again, the 0.01 and the 0.25. So this point here, 2, 5. So here we've got 2 points and we've got the coordinates of those points. Here we've got the first one, which is 0, 1. So 0 is along the corridor, 1's up the stairs, so that's x and y. We're going to call this one x1, y1, because that's our first point. Then we've got this point, and we're going to call this one x2, y2. In theory, if you label them the other way around, you'll still get the same answer at the end, but I tend to call the first point along the line x1, y1, and the second point x2, y2. That's what I just tend to do. Okay, now what we're going to do is we're going to substitute those values into the formula. So m, the gradient, is equal to y2, so y2 is equal to 5, minus y1, that's equal to 1, divided by x2, which is equal to 2, minus x1, which is 0. Now, if you notice here, we're just doing 5 take away 1. That's 5 take away 1. That's the rise. 5 take away 1. That's the rise, how much we're going up, which is 4. And 2 take away 0 stands for 2 take away 0. It's the run. It's 2. So we're doing the same thing as rise divided by run, but we're just using this formal formula for it. Okay, so m, the gradient, is equal to 5 take away 1. That's 4. And then 2 take away 0. That's 2. And then 4 divided by 2 is equal to 2. So the gradient of that line is equal to 2. So that's it. Now, I probably would either use the first approach or second approach to find the gradient of that line. I probably wouldn't use this approach for it, but some of the questions later on, I'll definitely be using that formula, y2 minus y1 over x2 minus x1. Okay, and let's just write down the gradient of the line is 2. Okay, let's look at our next question, question number 2. Okay, let's have a look at our next question, question number 2. So question number 2, we've got 2 points A and B, and we've got a line joining them. So we've got this line joining A and B. And we're told that AB is drawn on the grid, work out the gradient of AB. So now I'm going to use the first 2 approaches in this question. I'm going to do the little right angle triangle first of all. So I'm going to choose 2 points on the line. Well, I can clearly see this point's on the line A and this point's on the line B. I could have chosen this point here, the point 2, 2 or 0, 1. I would probably avoid points like this point here because I'm guessing that's 1.5, but it's good not to guess whenever you find the gradient of a line. So we've got these points. Let's make a little right angle triangle. So let's go across and then let's go up. And that's our little right angle triangle. And m, the gradient, is equal to the rise divided by the run. So m, the gradient, is the rise. Well, let's write down what the rise and the run are. Okay, so let's start with the run. Well, we're going from -2 across to 4. So the run is 6. We're going 6 units across. Again, I'm avoiding counting the squares. Again, this one's actually quite nice because it is just going across by 1 each time anyway and going up by 1 each time anyway. So that's quite a nice question, but it's not always the case. So just be careful there. So the run is 6. We're going 6 across from -2 to 4. And in terms of the rise, how much we're going up? Well, we're going from a height of 0 up to a height of 3. So the rise would be 3. So m, the gradient, is the rise divided by the run. The rise is 3 divided by the run, which is 6. So we've got m, the gradient, is 3 divided by 6. Now this is a non-calculator question, and I'm just going to cancel down this fraction. 3 and 6 are both divisible by 3. So 3 divided by 3 is 1, and 6 divided by 3 is 2. So the gradient of that line is a half. So that's it. So the gradient of this line AB is a half. So a half. And that's it. So that's one approach, and that's the approach that I would have used for that question, to make a little right angle triangle and do rise divided by run. Another approach, and I'm just going to get my rubber here and rub that out. Another approach would be to use inspection, and actually let's just check our answer for half is right. If we go across 1 unit, so going across 1 unit would bring us from -2 to -1, so we're going across 1, and then up a half, across 1, 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 up a half, and across 1, up a half. As you can see, the gradient is a half. Every time you go across 1 unit, you go up half a unit, across 1 unit, up half a unit, and so on. And I know that it's a half because after going across 2 units, we've got to 1, so we've gone up 1. So that means the gradient would be a half. Also, you could use m equals y2 minus y1 over x2 minus x1, but on this question, I probably would use one of the first 2 approaches. And that's it. So the gradient of that line is a half. Okay, let's look at our next question, question number 3. So question number 3, we've got another grid, and we've got the points A and C, and we've got the coordinates of both of those points. A is the point with coordinates -1, -4, and the point C is the point with coordinates 2, 5. And the question says to find the gradient of the line AC. So we want to find the gradient of that line. So if we want to find the gradient of that line, I probably would make a little right angle triangle. So I'd go across and up, and I'm going to choose the points A and C because they've been given to us and they're on the line, obviously. So it's a right angle triangle. And then let's write down the run and the rise. So in terms of the run, we're going from -1 across to 2. So from -1 across to 2, the run would be 3 because we're going from -1 to 2, we're going 3 units across. Again, this is a very nice question because every single time we go across one line, we're going across 1 unit. So you can see it's 1, 2, 3 boxes across, but that's not always the case. So here we're going across 3 units from -1 to 2. And then in terms of the rise, we're going from a height of -4 up to a height of 5. So the rise would be 9. So m, the gradient, would be the rise divided by the run. So the rise, m, is equal to the rise, which is 9, divided by the run, which is 3. And 9 divided by 3 is equal to 3. So the gradient of that line is 3. And let's just check it using the first approach. If we go across 1 unit, we got 3. If we go across 1 unit, we've got 3 units. If we go across 1 unit, we've got 3 units. So that's right, the gradient of that line is 3. And that's it. So the answer to that question is 3. Okay, let's look at our next question, question number 4. So question number 4, we've got this grid and we've got the line on it, the line L, and the question says to work out the gradient of that line. So we just need to work out the gradient of this line. So let's choose 2 points on this line. So I'm going to choose this point here, the point -2, 3, and I'm going to choose this point here, the point 0, -1. Now you may choose different points, and that's fine. Whenever you work out the gradient of the line, whenever you choose those points and you do the rise divided by the run, you'll still get the same gradient. So you have chosen this point and this point. Now this time, if you have a look at the line, it's actually going downwards, so it's going to have a negative gradient. If we look back at the other questions, the lines have been going upwards, so it's going up, but this time the line's going down, so instead of having a positive gradient, we've got a negative gradient. So let's make our little right angle triangle. So we've got our little right angle triangle going across and then down. The run, well, in terms of the run, well, we're going from -2 to 0. We're going from -2 to 0 there. So -2 to 0, the run would be 2. And in terms of the rise, well, we're going from a height of 3 down to a height of -1. So this time the rise would be -4. Because it's going downwards, the rise is -4 because it's going down. So m, the gradient, is equal to the rise divided by the run. M would be the rise is -4, the line's going downwards, so it's -4, divided by the run, which is 2. And -4 divided by 2 is equal to -2. So the gradient of that line is -2. And let's just check it using that other approach. If we go across one unit, we go down 2. Across 1, down 2. So the gradient of that line is -2. And that's it. Okay, let's look at our next question, question number 5. Okay, let's look at our next question, question number 5. So question number 5 says, Carolyn was asked to find the gradient of a straight line drawn on the grid below. So she's been asked to find the gradient of that line. And to find the gradient of the line, she chose 2 points A and B. So she chose these 2 points A and B, the point A, which is 0, 1, and the point B, which is 6, 4. And she's done this little right angle triangle. She's got here 6 going across and 3 going up. And it says that Carolyn says the gradient is equal to 2 because 6 divided by 3 is equal to 2. Is Carolyn correct? And explain your answer. Okay, so in terms of this line, if we want to find the gradient of this line, well, let's just check and make sure she's labelled the run and the rise correctly. So we've gone from 0 across to 6, so the run is 6, yes, and the rise is 3 because it's gone from a height of 1 up to a height of 4, so the rise is 3. So if we want to find the gradient of this line, we do m, the gradient, is equal to the rise divided by the run. And in terms of this line, the rise is equal to 3 and the run is equal to 6. And then we just cancel down that fraction. They're both divisible by 3. So if we divide both the numerator and denominator by 3, we get that's equal to a half. So that means the gradient of that line, m, is equal to a half and not 2 as Carolyn has said. And so the question is Carolyn correct? Well, the answer is no. What Carolyn's done is Carolyn's actually done the run divided by the rise. She's done 6 divided by 3, not the rise divided by the run. So let's explain that. And that's it. I've just explained that no, Carolyn has divided the run by the rise and not the rise by the run. And it should be 3 divided by 6, which is equal to half. So the gradient of that line is equal to half. Okay, let's look at our next question, question number 6. So question number 6 is George has been asked to find the gradient of a straight line drawn below. So he's been asked to find the gradient of this line. And the question says to find the gradient of the line, he chose 2 points on the line, A and B. So he's chose the points A and B. So A is the point 210 and B is the point 630. So he's got those 2 points and he's done this little right angle triangle and he's done, it says that George says the gradient is 2 because 4 divided by 2 is equal to 2. So George is saying the gradient of this line is equal to 2. Now, I know that's not correct because if we have a look here, in terms of the run and the rise, well, these numbers don't seem correct. The run, well, here we've got 2 across and it's gone to 6 across. So I'm just going to change colour ink here to blue. So if we go from 2 across to 6 across, the run will be 4 and not 2. So 2 is not right there in terms of the run. The run should be 4 because we're going from 2 across to 6 across. And then in terms of the rise, I can definitely see 4 is wrong here because this has got a height of 10 and this has got a height of 30. So the rise is actually 20 and not 4. So 4 is definitely wrong. And the rise should actually be 20, not 4. And then if we want to find the gradient of this line, the gradient m would be equal to the rise divided by the run. So m is equal to the rise, which is 20, divided by the run, which is 4. And 20 divided by 4 is equal to 5. So the gradient of that line is 5. It's not equal to 2. And let's just check that. If we go across one unit, we got 5. If we go across one unit, we got 5. If we go across one unit, we got 5. And you notice whenever I go across one unit, I'm only going to halfway because here the scale actually each of the lines is 2. So if we go across one unit, we got 5. If we go across one unit, we got 5. Across one unit, up 5, and so on. So George hasn't actually considered the scale. He's just looking at the boxes. And that's actually a very common mistake whenever people are dealing with gradient questions. Rather than actually looking at the scales and saying, well, the run is 4 and the rise is equal to 20, they'll just look at the little boxes and they'll incorrectly use the number of boxes rather than actually considering the scale. So let's explain that. And that's it. I've just explained that no, George has not considered the scale. The rise is 20 and not 4, and the run is 4 and not 2. And therefore the gradient is 5 and not 2. And that's it. Okay, let's look at our next question, question number 7. So question number 7, we've got this grid and we've got line A and line B. And the question says, part A, line A has been drawn on the grid, work out the gradient of line A. So let's get the gradient of line A. So we've got this line here, it's going upwards, so it's going to be a positive gradient, and let's find out what that gradient is. So let's choose 2 points on the line. I'm going to choose this point here, the point 6,6, and I'm going to choose this point here, the point 12,8. So we've got 6,6 is on the line and 12,8 is on the line. And I've chosen those 2 points, and I'm going to do a little right angle triangle, and then up. And in terms of the run and the rise, the run, well, we're going from 6 across, there's 6 across, to 12 across. So 6 across to 12 across, that means that the run's going to be 6. And actually, it's quite a nice scale here. Each time we go across one line, it's 1 unit, so it is 6 little boxes there in this particular case. In terms of the rise, we're going from a height of 6 to a height of 8, so the rise is 2. So the gradient m will be equal to the rise divided by the run. So that's going to be the rise is 2 divided by the run, which is 6. And if we simplify this fraction, 6 over 2, we divide both the numerator and denominator by 2, we get that's equal to a third. So the gradient of this line A is equal to a third. So, and let's just check that. If we go across 1 unit, we go up a third. If we go across another unit, we go up another third. If we go across another unit, we go up another third. And as you can see, a third, and a third, that's equal to 1. So over the course of going across 3 units, we've gone up 1. So that's right, across 3 units, up 1 unit, and so on. So that means the gradient is a third. So let's write that down, a third. And then part B says work out the gradient of line B. So we want to get the gradient of line B this time, so this line here. So if we want to find the gradient of line B, again, let's choose 2 points on that line. I'm going to choose the point here, 0, 10, it's on the line. Actually, just go up a little bit. And I'm going to choose another point on the line. I've got this point here, the point 2,5. So the point here, 2,5. And let's make a little right angle triangle and then going down, because obviously here it's going to have a negative gradient. It's going down. So in terms of the run, we're going to cross 2 units from 0 across to 2 across. So we're going to cross 2 units. And then we're going from a height of 10 down to a height of 5. So the rise will be -5 because we're going down 5 units. And so that means the gradient m is equal to the rise divided by the run. So m is equal to the rise, which is -5, divided by the run, which is 2. And if we do -5 divided by 2, that's a -2.5. So that means the gradient of this line is -2.5. Across 1 unit, down 2.5. Across 1 unit, down 2.5. And that would be right because we've gone down 5 altogether, and so on. And that's it. So let's write that down, -2.5. And that's it. And also you could write your answer as -5 over 2, so just leaving it as a fraction and rather than a decimal, and that's fine as well because 5 over 2 is -2.5. So leaving the gradient as a fraction is totally fine as well, or if you want to give it as a decimal, that's fine as well. Okay, let's look at our next question. Okay, question number 8. So question number 8, we've got this grid and we've got this line on the grid. And the question says, work out the gradient of the line shown. So we just need to find the gradient of this line. So let's choose 2 points on the line. I'm going to choose the origin. That's clearly on the line. And I'm going to choose this point here, the point 2,8. So here we've got these 2 points and we want to find the gradient of this line. So let's make our little right angle triangle and then go up. And it's a right angle triangle. Okay, so we've made our little right angle triangle there. We've chosen our 2 point 0, 0 and the point 2,8, and we've done our little right angle triangle. Now remember, the gradient is equal to the rise divided by the run. So we need to find out what the rise is and what the run is. So here if we have a look at this triangle, so in terms of the run, we're going from 0 across to 2 across. So the run is 2. We're going from 0 to 2. So the run is 2. So we're going 2 units across. And that's what I mentioned earlier in terms of being careful about the scale, because we're going from 0 across to 2. So we're not counting the little boxes. We're looking at the scale and saying, well, how many units are we going across? We're going 2 units across. And then in terms of the rise, we're going up from a height of 0 to a height of 8. So that means the rise is equal to 8 because we're going up 8 units. And again, we're not just counting the number of boxes because in terms of this question, the scale is not the same. We've got here the origin, and then we're going across 2 boxes to get to 1, and now across another 2 boxes to get to 2, across another 2 boxes to get to 3, and so on. We're going up vertically. Every time we've got 1 box, we're going up 2 units actually. So that means the rise would be 8 divided by the run, which is 2. And if we do 8 divided by 2, we get that's equal to 4. So the gradient of that line is 4. And let's just check that. If we go 1 unit across, we got 4. If we go across 1 unit, we got 4, and so on. And that's it. So the gradient of that line is equal to 4. So if we just write 4 in, that's it. That's the answer, 4. And that's it. And actually, one thing I just want to mention is I've actually been emailed about this question a few times where people have emailed me and said, well, hold on, the gradient of this line is equal to 1, because they think if you go across 1 box, you got 1 box, across 1 box, up 1 box. But you've got to be careful and look at those scales. So that's it. So the gradient of that line is equal to 4. Okay, let's look at our next question, question number 9. So question number 9, we've got this grid and we've got this line, and the question says to find the gradient of the line shown. So we need to find the gradient of this line. Okay, so let's find 2 points on the line. I'm going to choose this point here, the point 0, 4, and I'm going to choose this point here, the point 1, 0. And I'm going to make a little right angle triangle like so. And also just one thing I've noticed is the line's going downwards, so it's going to have a negative gradient. So here we've got our little right angle triangle. Remember that m, the gradient, is equal to the rise divided by the run. So the gradient m is equal to the rise divided by the run. Let's write down what the run and the rise are. So the run, we're going from 0 across to 1 across. So that means we're going 1 across, 1 unit across. And in terms of the rise, we're going from a height of 4 down to a height of 0. So the rise would be negative 4 because it's going down. Remember, it's got a negative gradient. So the rise would be negative 4. So the rise is negative 4 divided by the run, which is 1. And if we do negative 4 divided by 1, that's equal to negative 4. So the gradient of that line is negative 4. And that's it. So the gradient is equal to negative 4. And again, that's another question to be careful about, because if we look at that horizontal scale, it's not going across in ones, it's going across in actually in halves. So you need to be careful when you're finding that run that you're going 1 unit across rather than thinking you're going 2 across because it's to do with the boxes. You're going 1 unit across from 0 across to 1 across. So the run will be 1. Okay, let's look at our next question. So question number 10, we've got the sketch, we've got the x and y axis, we've got the point A, which is the point with coordinates negative 4, 1, and the point B with coordinates 6, 6. And then the question says find the gradient of AB. So we want to find the gradient of the line joining A and B. Now in terms of this question, there's a few different approaches we could use. One approach is actually just use the formula y2 minus y1 over x2 minus x1, or another approach is to do a sketch and to do rise divided by run. And I'm actually going to use both approaches. So let's start off by doing a sketch. So if I was doing a sketch, I'd get a ruler and pencil and I would join up the 2 points, so A and B, like so. And then I would do the little right angle triangle and label the run and the rise. So going across straight, hopefully, and down, and our little right angle. In terms of the run, well, we're going from negative 4 across the 6. So if we're going from negative 4 across the 6, the run would be 10, because to get from negative 4 to 6, you go across 10. In terms of the rise, this has got a height of 1, this has got a height of 6, so we're going up 5, the rise would be 5. And then if we wanted to find the gradient, m, that's equal to the rise divided by the run, and then the rise is equal to 5, the run's equal to 10, so we've got 10 divided by 5, that's a 0.5, or we could just cancel down the fraction to be that's equal to a half, because they're both divisible by 5, so then that would be a half. So the gradient of the line AB would be equal to a half, and that's it. That's probably the approach that I would use, because the sketch was there for us, so we could just actually just label on the run and the rise quite easily, and then do the rise divided by the run. Alternatively, you could use the formula, and I'll just do that now. And that's fine as well. So we could label the points x1 and y1 and x2 and y2. And then the formula for the gradient is m is equal to y2 minus y1, the rise, divided by the run, which is x2 minus x1. So let's substitute in the values. So m, the gradient, is y2, which is 6, minus y1, which is 1, divided by x2, which is 6, minus x1, which is minus 4. So we've got 6 minus 1 over 6 minus minus 4. So now let's work this out. So m is equal to 6 minus 1, that's 5, and then 6 minus minus 4, well, that's going to be 6 plus 4, which is 10. So we've got 5 divided by 10, and we can cancel that down again to be that's equal to a half. So the gradient of the line AB is equal to a half. And that's it. So you could use either approach, and actually both of them are quite straightforward. Okay, let's look at our next question, question number 11. So question number 11, we've got the point A with coordinates 1, 4, and the point B, the point with coordinates 7, 22. And we've been asked to find the gradient of AB. Now, if I was doing this question, I would probably use the formula. I would use m is equal to y2 minus y1 over x2 minus x1. And I'm going to use that approach first because that's the approach that I would use first. And then what I'm actually going to do is I'm going to actually do a little sketch to show you that you can actually just do a sketch as well and use rise over run as well. And that's totally fine as well. Okay, so let's label the points. I'm going to label the point A, x1, y1, and the point B would be x2, y2. So we've labelled the points, now let's substitute them in. So m, the gradient, is equal to y2, which is 22, minus y1, which is 4, divided by x2, which is 7, minus x1, which is 1. So we've substituted in the values of x1, y1, and x2, y2 into the formula. And that will just tell us the rise divided by the run. So m is equal to 22 taken away 4 is 18, divided by, and then 7 minus 1 is equal to 6. So we've got 18 divided by 6, so m, the gradient, would be equal to 3. So the gradient of AB is equal to 3. So that's one approach, is actually just use the formula, and I think that's totally fine. Another approach is to do a sketch, and if I was doing a sketch here, what I would do is, I would look at the first point, which is the point 1, 4, and I would just plot a point. That's the point A, which is the point with coordinates 1, 4. Then the point B, let's figure out where that would be in relation to it. So if this is 1 across and 4 up, B is 7 across and 22 up. So it's going to be further across and further up. So it's going to be up there somewhere. Because obviously if this one is 1 across and 4 up, if you go 7 across and 22 up, you're going to go up even higher. So that's the point B. And that's the point 7, 22. You could, if you want to, actually do the x and y axis as well. So you could do the y axis and the x axis as part of your sketch as well, and that's totally fine. Now what I'm going to do is I'm going to join them up, A and B, and I'm going to do a little right angle triangle, and I'm going to find the rise and the run. So here, if we just do a little right angle triangle, we've got a right angle triangle. The run, so that's how far you're going to go across. So we're going from 1 to 7 across. So from 1 across to 7 across, the run will be 6. So that's the run. And then in terms of the rise, we're going from a height of 4 up to a height of 22. So the rise would be 18. So we've got m, the gradient would be 18, the rise, divided by the run, which is 6, and 18 divided by 6 is 3. So the gradient of that line is 3, and that's it. Okay, let's look at our next question, question number 12. Okay, let's look at our next question, question number 12. So question number 12 asks us to work out the gradient of the line that passes through the points -4, 5 and -1, 11. Okay, so we've got these 2 points and we want to work out the gradient of the line passing through the points. So I'm going to use the formula m, the gradient, is equal to y2 minus y1 over x2 minus x1. Okay, so let's label the points. So the first point I'm going to call x1, y1, and the second point I'm going to call x2, y2. So now let's substitute those values into the formula. So m, the gradient, is equal to y2, so that's 11, minus y1, and that's equal to 5, all over x2, which is -1, subtract, and then x1, which is equal to -4. And so that means that m is equal to, and let's work out the numerator and the denominator. So 11 take away 5, that's equal to 6. And then in terms of the denominator, we've got -1 minus -4. So that's going to be -1 plus 4. And if you go 4 up from -1, you get to 3. So that's equal to 3. So we've got m, the gradient, is equal to 6 divided by 3, and 6 divided by 3 is equal to 2. So that means the gradient of the line that passes through the points -4, 5 and -1, 11 is equal to 2. And that's it. Okay, so that was one approach to use the formula. Another approach is to do a little sketch. So we could get a ruler and pencil, and we can do the x-axis and the y-axis, like so. And then we can plot where the points would roughly be. So -4, 5 would be -4 and 5 would be up there somewhere. And then the next point, which is -1, 11. So -1 and then 11's a bit higher up, so about there. So we've got the points -4, 5 and -1, 11. So if we wanted to find the gradient of the line that goes through those points, we would just do a little sketch by then joining them up, like so. And actually we should really label the points. So we've got -4, 5 and we've got -1, 11. And as you can see, this one's a bit closer to the y-axis and it's a bit higher up, and that's why I've put them like that in relation to each other. And then if we wanted to find the gradient of that line, we do a little right angle triangle and label the rise and the run. So the run, we're going from -4 to -1, so we're going to cross 3, so the run would be 3. And in terms of the rise, we're going from a height of 5 up to a height of 11, so the rise would be 6. And then we would just do the rise divided by the run, so we would do 6 divided by 3, and that's equal to 2. So that would work as well. So some people just like to use the formula, and some people like to do a sketch, and that's it. Okay, let's look at our next question, question number 13. So question number 13, we've been asked to work out the gradient of the line that passes through the points 3, 2 and 7, 20. So again, I'm going to use the formula first. M is equal to y2 minus y1 over x2 minus x1. Let's label the point. So the first point, let's call that x1, y1, and the second point, x2, y2. And let's substitute those values in. So m, the gradient, will be equal to y2, that's 20, minus y1, that's equal to 2. Okay, so now if we have a look at the denominator, x2 minus x1, so x2 is equal to 7 and x1 is equal to 3. So let's work this out. So m is equal to 20 take away 2 is 18 and 7 take away 3 is equal to 4. So we've got 18 divided by 4, and if let's divide 18 by 4, so let's half it and half it again. Half of 18 is 9 and half it again is 4.5. So that means the gradient of the line that passes through those points is 4.5, and that's it. Alternatively, we could do a sketch. So we could sketch our x and y axis, so our x-axis and our y-axis. We've got our 2 points. We've got the first point, 3, 2. So 3 along, 2 up will be about there. And remember, it's just a sketch. But now in terms of our next point, 7, 20, it's going to be further along and further up. So it's going to be up there somewhere. So I'm just doing a sketch and making sure I'm putting this point up above this one and to the right. So just so in relation to this one, it's a bit further to the right and a bit further up. And now if we join them up, we can then make our little right angle triangle and work out the gradient of the line that passes through those points. So if we go across and up, and this point was the point 3, 2, and this point is 7, 20. So in terms of the run, we're going from 3 across to 7 across, so the run is 4, And in terms of the height, we're going from 2 up to 20, so the rise would be 18. And then we do rise divided by run, so we do 18 divided by 4, and that's equal to 4.5 again. So that's it. Okay, let's look at our next question, question number 14. So question number 14 says, work out the gradient of the line that passes through the points -8, -20, and -1, 22. Okay, so let's use the formula. M is equal to y2 minus y1 over x2 minus x1. And let's label our points. The first point, x1, y1, and our second point, x2, y2. Okay, so we've labelled the points. Now let's substitute in the values. So M is equal to y2, that's 22, minus y1, that's equal to minus 20, all over x2, that's equal to -1, minus x1, that's equal to minus 8. And now if we work this out, M is going to be equal to 22 minus minus 20, so 22 plus 20 would be 42. And then in terms of our denominator, -1 minus minus 8. So minus and minus 8 means we're going to add 8 on. So -1 plus 8, if we go back up, it would be 7. And that means the gradient M will be equal to 42 divided by 7, and that's equal to 6. And again, instead of using the formula, we could just do a sketch and do the sketch like so. We've got our x-axis and our y-axis. I'm just going to move them slightly so it's a bit more central. So we've got our x-axis and y-axis. The first point was -8, -20. So -8 would be across there somewhere, and -20 would be down there. So that's the first point, -8, -20. And then the second point is got coordinates -1, 22. So it'll be up there somewhere. So that's going to be -1, 22. So we've got our 2 points. Now let's join them up. So if we join up those points, so it would look something like that if we join them up. And then we can make our little right angle triangle. So we're going to cross and up. And then that's a right angle. In terms of the run and the rise, well, this one we're at -8, and we're going to cross the -1. So the run will be 7. And in terms of the rise, we're going from -20 all the way up to 22. So the rise would be 42. And then again, we would do rise divided by run. So we do 42 divided by 7, and that's equal to 6. And that's it. Okay, let's look at our next question, question number 15. Okay, so question number 15, we've got this graph and we've got this line called line L. And the question says, line L is drawn on the grid, work out the gradient of line L. So we want to work out the gradient of this line. So if we want to work out the gradient of this line, we're going to choose 2 points on the line. So I'm going to choose this point here, and I'm going to choose this point over here. So I've chosen these 2 points. This is the point with coordinates. Let's just write down what the coordinates of this point are. So we've got 10 there, so 10 across. And then in terms of the height, we've got 80, 120, so in the middle would be 100, so that'll be 10 and then 100. So that's the coordinates of that point. In terms of this point here, the coordinates of this point up here would be, well, it's 50 across, so 50 across. And in terms of the height, it's in between 160 and 200, so that'll be 180. So that would be 50, 180, so 50 across, 180 up. So we've got our 2 points. Okay, so now let's do a little right angle triangle, so it looks something like this. And then label our rise and our run. So in terms of our run, we're going from 10 across to 50 across, so the run would be 40. We're going 40 across there. And then in terms of the rise, we're going from a height of 100 up to 180, so the rise would be 80. So we've got the run of 40 and the rise of 80. And then if we wanted to work out the gradient, M, that's equal to rise divided by run. So M would be equal to 80, the rise, divided by the run, which is 40. And 80 divided by 40 is equal to 2. So the gradient of that line is 2. And that's it. Let's write that down. The gradient of that line, L, is 2. Okay, let's look at our next question. Okay, it's question number 16. Question number 16, we've been asked to work out the gradient of the line that passes through the points 120, 1100, and 200, 3500. Okay, so this time I'm going to use the formula. I could do sketches if I wanted to and sketch where those points would be. So 120, 1100 there somewhere, and then 200, 3500, so further to the right and further up, and then join them up and do a little sketch. I'm just going to call them x1, y1, and x2, y2. So now M, the gradient, is equal to y2 minus y1 over x2 minus x1. And let's substitute in those values. So M, the gradient, would be equal to y2, that's 3500, minus y1, that's 1100. And that's all over x2, which is 200, minus x1, which is 120. And then if we work this out, M is equal to the numerator, 3500, take away 1100, would be 2400. And that's over, the denominator would be 200, take away 120 would be 80. So we've got M, the gradient, is equal to 2400 divided by 80. Now it's a calculator question, so you can just type this into the calculator and work it out, and you'll get an answer of 30. So the answer is 30, and that's it. The gradient of the line would be 30. So that means that the gradient of the line that passes through the points 120 and 1100 and 200, 3500 would be 30, and that's it. Okay, let's look at our next question, question number 17. Okay, let's look at our next question, question number 17. So question number 17, we've got this grid, we've got the x and y axis, and we've been asked in part A to draw the graph of y equals 4x plus 2. So we want to draw the graph of y equals 4x plus 2. So I'm going to do a little xy table, so x and then y, and I'm going to choose some values for x. I'm going to choose 0, 1, and 2. And because y equals 4x plus 2, what we're going to do is we're going to multiply all the x coordinates by 4 and then add 2. And feel free to go back to Corbettmaths and go to the videos and worksheet section and scroll down to the video on drawing linear graphs, and there's a dedicated video tutorial there on drawing linear graphs, and it recaps this topic, so how to draw these linear graphs by doing xy tables. So we're going to multiply all the x coordinates by 4 and then add 2. So 4 times 0 is 0, add 2 is 2. 4 times 1 is 4, plus 2 is 6, and 4 times 2 is 8, plus 2 is 10. So we've got our points 0, 2, so 0, 2, 1, 6, so that's 1 across 6 up, and 2, 10, so 2 across and 10 up. So we've now got these 3 points. Now we're going to draw a nice straight line through them. So get a ruler and pencil and draw a nice straight line through those points. So that's the line with equation y equals 4x plus 2. Okay, and then part B. Part B says write down the gradient of the line y equals 4x plus 2. So we want to write down the gradient of that line. Now, if you've learned the equation of a line, y equals mx plus c, you'll see that it's 4 straight away. The number in front of the x, the coefficient of x, is the gradient of the line, so that's 4. Let's go up here and see why. So here we've got our line, and we want to find the gradient of this line, so let's choose 2 points on the line. So I'm going to choose the point 0, 2, and 1, 6, because we used those earlier. And let's do a little right angle triangle, so we're going across and up. So in terms of this is the point 0, 2. This is the point 1, 6. So the run will be 1. We've got 1 unit across. And in terms of the rise, we're going from a height of 2 up to a height of 6. So the rise would be 4. And then the gradient m will be equal to the rise divided by the run. And if we do the rise, which is 4, and we divide that by the run, which is 1, 4 divided by 1 is 4. So that means the gradient of that line is equal to 4. And that's it. So the gradient of that line is 4. Okay, let's look at our next question. Okay, question number 18. So we've got this grid, and part A, we've been asked to draw the graph of y equals 2y plus x equals 20 on the grid above. So we've been asked to draw that graph, 2y plus x equals 20. So again, I'm going to do a little xy table, x and y. And this says that 2 times the y coordinate plus the x coordinate is equal to 20. So let's choose some values for x. So I'm going to choose 0, 1, and 2. And we're going to substitute them into here, the value for x, and we're going to find out what the value for y would be. So let's start off with 0. So we've got 2y, and then we're going to add x, so we're going to add 0, so adding 0. Well, I'm not going to write add 0, I'm just going to write 2y, and that equals 20. And then if we divide both sides by 2, we get y is equal to 10, so that would be 10. Okay, next, if x is equal to 1, we've got 2y, so 2y, plus x, so that's going to be plus 1, is equal to 20. So just put the 1 in there instead of the x. Now we're going to solve this equation. We're going to take away 1 and take away 1, and we get that 2y is equal to 19, just taking away 1 from both sides. On the left-hand side, it gets rid of the plus 1. On the right-hand side, it gives us 19. And then we're going to divide by 2 and divide by 2, so we get that y is equal to, and half of 19 is equal to 9.5. So that means that the y coordinate would be 9.5. Okay, and then finally 2, we've got 2y plus x, so it's going to be 2y plus 2 because x is equal to 2, and that's equal to 20. If we take 2 away from both sides, we get that 2y is equal to 18, just taking away 2 from both sides, and then dividing both sides by 2 would give us that y is equal to 9. So that means that y is equal to 9. So that means we've got 3 points. We've got 0, 10, 1, 9.5, and 2, 9, and they're the coordinates of 3 points. Now I just want to mention, rather than doing an xy table and substituting the values in here, you could rearrange this and make y the subject, and if you've revised changing the subject and you're happy with that, feel free to, but I've just substituted them in and solved the equations to find out what the values for y would be. Okay, let's plot them because we've been asked to draw the graph. So 0, 10 would be there, 1, 9.5 would be there, and 2, 9 would be there. And let's get a ruler and pencil and draw a nice straight line through those points. And that's it. That would be the graph of 2y plus x is equal to 20. Okay, and then if we scroll down, part B, we've been asked to work out the gradient of that line. So we want to work out the gradient of that line. So let's go back up and find the gradient of this line. And I'm going to choose 2 points on the line. I'm going to choose this point here, 0, 10. So one of the points I'm going to choose on the line is 0, 10. I could choose 1, 9.5 or 2, 9 if I wanted to. I'm actually just going to move over a bit here. I'm going to choose this point here. I'm going to choose the point here, 10, 5. So this is the point 10, 5. Now, as I said, I could use 1, 9.5 or 2, 9, but I've just chosen the point 10, 5 so that whenever I do this question, you can actually see it a bit more clearly on the video. Okay, so now what I'm going to do is change colour of ink to blue, and we're going to do a little right angle triangle. Now, just to mention here that the line is going down, so it will have a negative gradient. So the run, we're going to go across, so we go across to here, and then we're going to go down. In terms of the run, we're going from 0 across to 10 across there, so 0 across to 10 across, so the run would be 10. And in terms of the rise, we're going from a height of 10 down to a height of 5, so the rise would be negative 5 because it's going down 5, so the rise would be negative 5. So m, the gradient, will be the rise divided by the run, so the rise is negative 5 and the run is 10. And if we do negative 5 divided by 10, that's equal to minus 0.5 or minus a half, and that's it. So m, the gradient, would be minus 0.5 or minus a half. And that's it. Okay, let's look at our next question. Okay, let's have a look at our next question, question number 19. So question number 19 says the point A has got coordinates 1, 3, and the point B has got coordinates 8p. And the question says that the gradient of the line AB is equal to 2. So the gradient of this line is equal to 2, and we've been asked to work out P, so the y coordinate of the point B. Okay, so we've got a little sketch here, so I'm going to use our little triangle. So I'm going to do a little right angle triangle, like so. So we've got our little right angle triangle, and we know the gradient of the line is equal to 2. So I know that the rise divided by the run will give us an answer of 2. Now we know that this one is 1 along. We know that the point A is 1 along the corridor, and we know that the point B is 8 along the corridor. So the run will be 7. We know that the run's going to be 7 because it's 7 across, going from 1 across to 8. In terms of the rise, well, because we know the gradient of the line is equal to 2, we know that m, the gradient, is equal to the rise divided by the run. So the gradient is 2, and we've got that's equal to the rise divided by the run, but the run is equal to 7. So if we wanted to work out what the rise was, we just need to multiply both sides by 7. So if we multiply the left by 7 and the right by 7, 7 times 2 is equal to 14, and then that just gives us the rise. So it means the rise has to be equal to 14. Now you may have just looked at that and said, well, if the gradient's 2, that has to be 14 because 14 divided by 7 is equal to 2, and you may have just worked that out by just looking at it. So we know that that's equal to 14 in terms of the rise. Now the height of A was 3, and then we're going up another 14. So that means if we do 3 plus 14, 3 plus 14 is equal to 17. So that means the P will be 17. So that means the coordinates of the point B are 8, 17. But we were just asked to work out the value of P, so the value of P will be 17. And that's it. So let's write that down, 17. Okay, let's look at our next question, question number 20. So question number 20 says that the point A has got coordinates negative 3, 16, and the point B has got coordinates Q, negative 8. And the question says that the gradient of this line is equal to negative 3, and we've been asked to work out Q, so the x coordinate of this point here. Okay, so we've got a sketch drawn for us, so let's do our little right angle triangle. So let's go across and then down. So we've got our right angle triangle. In terms of the run, well, we don't know the run yet because we don't know how far along the corridor it is. So in terms of the rise, well, because the gradient of this line is negative, it's going down. We know the rise will be negative because we're going downwards, and we're going down 24 because if you're at 16 and you want to get down to negative 8, you're going to go down 24 altogether. So the rise will be negative 24. So that's fantastic. We've now got the rise. So remember the gradient m is equal to the rise divided by the run. So we know the rise divided by the run will be equal to negative 3. So that means that negative 3 is equal to the rise, which is negative 24, divided by the run. And actually, if you just look at this, if we want to divide negative 24 by something to get an answer of negative 3, that'll be 8, because negative 24 divided by 8 will be negative 3. Because remember, a negative divided by a positive is a negative, and 24 divided by 8 is 3. So it means the run will be equal to 8. And that's it. And you might have just looked at this and said, well, if I wanted to divide minus 24 by something and get an answer of negative 3, it'd have to be 8. So it means the run's equal to 8. Now this point is negative 3 along the corridor, and we're going across 8. So that means that if you're at negative 3 and you go across 8, you're going to get to 5. So that means that Q would be equal to 5. And that's it. That's the value of Q. Q is equal to 5. Okay, so question number 21. Question number 21 says the line that passes through 4, negative 7 and 8c has got a gradient of 3. And we've been asked to find c, the y coordinate of this point. So we haven't got a sketch here, so I'm actually just going to use the formula for this question, just to show you can use the formula as well. So m, the gradient, is equal to y2 minus y1 over x2 minus x1. And let's just label the points. The first point will be x1, y1, and the second point will be x2, y2. Okay, so we've labelled them. Now let's substitute those into our formula. So m is the gradient, and we're told the gradient's equal to 3. So I'm just going to write 3 there. And that's equal to y2, that's equal to c, minus y1, that's equal to minus 7. And that's all over x2, which is 8, subtract x1, which is 4. So we've substituted in the values. Now we just need to solve this and figure out what c is going to be. Okay, so in terms of our denominator, 8 take away 4 is equal to 4. So 3 is equal to, and actually just going back up to the numerator here, we've got c minus minus 7. Now remember, your minus and a minus, that means you're going to be adding it. So I'm just going to write c plus 7 there. So rather than minus minus 7, we've got plus 7. And that's all divided by 4, because 8 take away 4 is equal to 4. And this is fantastic. We just need to solve this equation now. Now, if I wanted to solve this equation, the first thing I would want to do is get rid of this big divide by 4. So I'm going to do the opposite. I'm going to multiply both sides by 4. 3 times 4 is equal to 12. And then on the right-hand side, we have c plus 7. We're multiplying by 4 to get rid of the divide by 4. So we're just going to be left with c plus 7. So we've got, I'm just going to write up here, 12 is equal to c plus 7. Now we want to find out what the c is, so we want to get rid of this plus 7. So let's take away 7 from the left-hand side and take away 7 from the right-hand side. 12 take away 7 is equal to 5, and then on the right hand side we had c plus 7. We're taking away 7 to get rid of the plus 7, so we're just going to be left with c. So it means the c is equal to 5, and that's it. So just to recap on this question, I labelled the points x1, y1 and x2, y2, and the gradient was equal to 3, so we used the formula m is equal to y2 minus y1 over x2 minus x1. We substituted in all those values, and then we just solved that equation, and we found that c was equal to 5. Okay, let's look at our next question, question number 22. So question number 22 is quite similar, where we've got a line that passes through the points 6, negative 4 and a 10, and we're told the gradient of that line is equal to 2, and we've been asked to find a. Okay, so let's label the points x1, y1 and x2, y2. And we know the gradient of the line is equal to 2, so m is equal to 2. So let's write down the formula. M is equal to y2 minus y1 over x2 minus x1. So that's the formula to find the gradient of the line. So let's substitute in our values. So we've got m, the gradient, which is equal to 2, is equal to y2, so y2 is equal to 10, minus y1, y1 is equal to negative 4, so minus minus 4. And that's over x2, so x2 is equal to a, minus x1, which is equal to 6, so minus 6. Okay, so let's work this out. We've got 2 is equal to 10 minus minus 4, so it's going to be 10 plus 4, which would be 14, over a minus 6. Okay, we're almost there. Now, if I wanted to solve this equation, I don't like the fact that a is under the denominator, so I want to get rid of this a on the denominator, but it's all divided by a minus 6, so I'm going to multiply both sides of the equation by a minus 6. So if I multiply the left-hand side, actually let's write that down. Let's multiply the left-hand side by a minus 6, and let's multiply the right-hand side by a minus 6. Okay, 2 multiplied by a minus 6 would be 2 and then brackets a minus 6. And the right-hand side, we're multiplying by a minus 6 to get rid of the divide by a minus 6, so we just be left with 14. So this is fantastic. Let's write this up here. 2 brackets a minus 6 is equal to 14. And then if we wanted to solve this, let's expand the brackets. 2 times a is 2a, and 2 times minus 6 would be minus 12. Just multiplying what's inside the bracket by 2, and that's equal to 14. And then let's add 12 to both sides to get rid of this take away 12. So add 12 and add 12. On the left hand side, we'll just be left with 2a. And on the right hand side, we've got 14 plus 12. That's equal to 26. And then finally, we want to get rid of this times by 2. So let's divide by 2 and divide by 2. And we get a is equal to 13. So that means a is equal to 13. And that's it. Okay, let's look at our next question. So question number 23, we've got this diagram. We've got the points A and B. And we're told that A is the point with coordinates 3, 1. So 3, 1. And the point B is the point with coordinates A, 11. And we've been told that the gradient of this line is 5 over 2. And we've been asked to work out A, so little a, the x coordinate of the point B. So what we're going to do is let's label the points x1, y1 and x2, y2. So we've labelled the points x1, y1, x2, y2, and we know the gradient of the line is equal to 5 over 2. So m is equal to y2 minus y1 over x2 minus x1. So let's substitute in our values. M, that's equal to the gradient, 5 over 2, so 5 over 2, is equal to y2 minus y1, so y2 is 11, minus y1, which is equal to 1, over x2, which is a, little a, minus x1, which is 3. Okay, so let's solve this equation. So what I'm going to do here is, well, 5 divided by 2, it's a calculator question, you can just work it out. Half of 5 is 2.5, so we've got 2.5 is equal to, and then we've got 11 minus 1, that's equal to 10, over a minus 3. So I've just done two things there. I've changed that fraction to a decimal, just because it's going to be a bit easier when we expand the brackets in a minute. And then also I've worked out what the numerator is going to be, because 11 minus 1 is equal to 10. Okay, now we want to solve this equation, and we want to find out what little a is. It's on the denominator. I don't like this big divided by a minus 3, so let's get rid of this divided by a minus 3. So let's multiply both sides by a minus 3, and so that's the left-hand side and the right-hand side. Okay, in terms of the left-hand side, we've got 2.5, and then in brackets a minus 3. When you're multiplying 2.5 by a minus 3, I would just put it beside it and keep the brackets there, and we'll expand those in a minute. And then in terms of the right-hand side, we have 10 divided by a minus 3. We're timesing by a minus 3 to get rid of the divided by a minus 3, so we'd just be left with 10. So we've now got the 2.5 times a minus 3 is equal to 10. We could, if you wanted to at this point, divide both sides by 2.5 and you actually get that a minus 3 is equal to 4, and then you'll be able to solve that and get a is equal to 7. Or you can multiply the brackets. 2.5 times a would be 2.5a, and then minus, and 2.5 times 3 would be 7.5, and that's equal to 10. Okay, we're nearly there. Okay, so now we're going to add 7.5 to both sides. So add 7.5 to the left-hand side and add 7.5 to the right-hand side. On the left-hand side, we're adding it to get rid of the minus 7.5, so we're left with 2.5a. And then on the right-hand side, we've got 10 plus 7.5, so that'll be 17.5. Okay, we're almost there. We want to get rid of this multiply by 2.5, so we're going to divide by 2.5 and divide by 2.5. 2.5a divided by 2.5 will just leave us with a, and 17.5 divided by 2.5 is equal to 7. So a is equal to 7, and that's it. We'll find out what a is. A is equal to 7. So little a, that x coordinate of the point B, is equal to 7. And that's it. Okay, let's look at our next question, question number 24. So question number 24, we're told that the line passing through the points 4, little a, and 8, 1 has a gradient of 3/4, and we've been asked to work out little a. So we want to find this y coordinate of this point. Okay, so let's label the points x1, y1, and x2, y2. And we're told the gradient is equal to 3/4, so m is equal to 3/4. So let's write down the formula. M is equal to y2 minus y1 over x2 minus x1. So m, the gradient, so m is equal to 3/4, so 3/4, or I might change that to 0.75 in a minute if I wanted to, is equal to y2, that's equal to 1, minus y1, that's equal to a, and that's over x2, which is 8, minus x1, which is 4. So we've got that 3/4 is equal to 1 minus a over 8 minus 4. Let's simplify this denominator. So we've got 3/4 is equal to 1 minus a over, and then 8 minus 4 is equal to 4. Okay, so we're almost there. Now actually at this point, there's a little bit of a shortcut here. We've got the 3/4 is equal to 1 minus a over 4. Both of the denominators are the same. So if both of the denominators are the same, so that means the numerators must be same as well. So 3 must be equal to 1 minus a. So you can actually go straight to that point that 3 is equal to 1 minus a. And actually, let's just do that. The 3 is equal to 1 minus a. So I'm actually just going to do this part twice. So I've just said that 3 must be equal to 1 minus a because the numerators must be equal to each other. And then if I wanted to solve this, I would add a to both sides. So add a to the left-hand side and add a to the right-hand side. 3 plus a would be 3 plus a. And the right-hand side, you'd just be left with 1 because you're adding the a to get rid of the minus a. And then we want to find out what a is, so we could just take away 3 and take away 3. And on the left-hand side, you just be left with a. And on the right-hand side, we've got 1, take away 3. That's equal to negative 2. So it means that little a is equal to negative 2. And that's it. Alternatively, if you didn't spot the fact you could just go straight to that point, the fact that the two numerators are equal to each other, what you could do at this point is, there's a few different approaches. One approach is to, like our last question, change this to a decimal to be 0.75 because 3/4 is 0.75, and that's equal to 1 minus a over 4. You could then get rid of the divide by 4 by timesing both sides by 4, and 0.75 times 4 would be equal to 3, and that's equal to, and we're multiplying by 4 to get rid of the divide by 4, so we're left with 1 minus a. And again, you could add a to both sides to get that 3 plus a is equal to 1, and then take away 3 and take away 3, and you get that a is equal to minus 2 again. And that's it. So a is equal to minus 2. Okay, let's look at our last question, question number 25. Okay, so question number 25 says a straight line passes through the points M, N, and P, Q. And given that P is equal to M plus 6 and N is equal to Q minus 18, and we've been asked to find the gradient of the line. So what I'm going to do here is, here we've got M, N, and P and Q, but we're told that P is equal to M plus 6. So I'm going to replace this P with M plus 6. And we're also told that N is equal to Q minus 18. And I'm going to replace this N with Q minus 18. So let's do that. So we've got M, and then instead of N, we've got Q minus 18, so Q minus 18, that's that point. I'm just going to put a comma in there, that's a comma. And then in terms of this point, we had P, but that's equal to M plus 6, what we're told in the question, and then we've got Q. Okay, so we've got our points now, and they've just got m's and q's in terms of the letters, the variables, and we've got here m, q minus 18, and then m plus 6, q. Okay, now what I'm going to do is I'm going to use the formula. So I'm going to call this point x1, y1, and this point x2, y2. Okay, so remember the gradient m is equal to y2 minus y1 over x2 minus x1. Okay, so m, the gradient, well, that's what we're trying to find. M, the gradient, is equal to y2. So y2 is equal to q minus y1. That's equal to, I'm going to put it in brackets, q minus 18. So we've got q minus 18. And then in terms of our denominator, we've got x2, that's m plus 6, so m plus 6. And then we're taking away x1, which is m, so minus m. So we've just substituted our values for y2, y1, x2 and x1. Now let's see if we can do any simplifying. So if we have a look at the numerator here, we've got q minus 18. Well, q minus q is 0. But then we're also taking away minus 18. And when you minus a minus, you add it on. So you've got q minus q, which is 0. But then you're going to be adding on 18. So the numerator would just be 18. And then in terms of the denominator, we've got m plus 6 minus m. Well, m plus 6, take away the m, would just be 6. So we've got the m is equal to 18 divided by 6, and that's 3. So that means the gradient of the line is 3. And that's it. And that's it. So these have been the video solutions to the Corbettmaths Practice Questions on the gradient. If you need any extra help on the gradient, if you go to the videos and worksheets section of the website and you scroll down to video numbers 189 and 190, there's dedicated video tutorials there on the gradient. Alternatively, you can scan this QR code. But in this video, we went through the video solutions to the practice questions. I really hope you found it useful. If you have found it useful, please like it and please subscribe to the YouTube channel. Thank you. Cheers. Bye.